Welcome back. So far, processing has been a tool that can create simple shapes on a dynamically sized canvas, but all in all, not too interesting. The reason people use processing, and the biggest advantage it has for graphics, is that it's a programming language. So there are computer science concepts here that apply to creating images effectively. Don't worry, I promise this won't go over your head. I'll explain everything as I go along. I've come back to the project we worked on last episode, and the only thing I've changed is that I've added comments telling us when the program starts drawing specific things, like feet and arms. So it's quicker to find what to edit if I want to make the legs longer or something. To do that, type 2 slashes, like this. Then type your comment. This is the sun, and head. If it's grayed out, that means the program will ignore it and not try to run any commands off of that. Perfect for little notes. To do a multi-line comment, type a slash and an asterisk like this. Then you can return and type as many things as you want. Then to end that multi-line comment, you simply do an asterisk and then an ending slash. This is a great way to comment out large parts of your code that you don't want to run and you want to see what it looks like without it. But I don't really need a multi-line comment in my code right now, so I'll just get rid of that. I want to change the torso of this guy and move it to another point to have him in a different pose, like here. To do this, I would need to change the ending point of every line. Here, 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 and here. Oh, and don't forget here and here. Or I could use variables to do it all in one step. I can do that by defining a variable here. It's common to have your variables defined at the beginning of the program because you can't use a variable before you define it. So I'll do it right at the top. To create a variable, type the type of variable first, what the variable is going to be, a number, a string, a decimal. In my case, I want it to be a whole number, so that would be an integer. So I just type in int, and processing recognizes that that's going to be an integer. Now I want to type the name of my variable, so I would go torso x. Now the equal sign is an assignment operator, and that tells processing what value that variable is going to be. X is going to be 230 by default, so I'll put in 230. And make sure you end that with a semicolon. Now, if you're reading this and it looks like torsox to you, you could capitalize the X so it looks more like torso X. It's currently throwing an orange error, which isn't going to be a problem when you run the program, but it's just confused why you have a variable called torso x and not using it. But we will soon enough. Let's create another integer for the y component. Now to use both those variables, let's copy and paste that where we want that, as the ending point here, the starting point here, and here, then copy that, make that the ending point here, starting point here, here. Now if you run the code, nothing changes. That's because the variables are still the same values. But if I want to change that to something like 250 and 340, now he has a sassy swing in his step. If I don't like that, I can change it again to something like 260, 390. Now he's sitting down. If I want to go back to where I was, I can type in the original values, which were 230 and 340. If I don't remember what it is, I should leave a comment, something like default spot 230, 340. That way I can remember what the original value is if I want to change back. So now I can easily change wherever that point is with changing just 2 values instead of having to change 6 values. This is way more efficient. Let's have another example of variables by making some clouds. So to make some clouds, I'll go to the end of my program and type in circle 150, 50, 20. Then another circle 165, 50, 30. And then another circle for the last bit of the cloud. 180, 50, 20. Let's see what that looks like. Ah, well that is the right shape, but I don't want the stroke or the lines around the circle to still be there. I want it to blend together. I can do that with the no stroke command. Ah, that's much better. Now if I want to make another cloud, I should copy and paste all of this to do it again. But I need to increment it by a certain amount. So the Y value is fine, but I guess I should increment it by 200, 215, 230. That's a little bit too close together, so I'm going to have to increase that by 10. Okay, that's all right. But I think I should use another cloud. Ugh, I don't want to copy all of this over again. So maybe variables can make it easier. Let's create a variable called cloudx. Because that's the main thing I'm changing. Everything else can stay the same. And then I copy cloudx plus 15, because I'm adding 15 to the next circle. And then cloudx plus 30, because I'm adding 30 to the next circle. 15, another 15, 30 from the original circle. And now I can set cloudx to increase by a certain amount, let's say 60. So now I can copy the exact same group of commands and paste them here. Ah, now it's 2 circles, and I can just copy and paste this code right here. And now I have 4 clouds, easy as pie. But there is a problem. Obviously, this code looks way too similar, and it looks a little confusing. This is a very obvious pattern in code, and there's a way to make this a lot simpler by using a for loop. So let's get rid of everything I have so far, except the important bits. 1 cloud and increasing cloud x. Now, to write a for loop, type for, then in the parentheses, create the counter variable, which is traditionally an integer called I. And let's set that to 0. Then with a semicolon, type in when you want I to stop. Let's say I want 5 clouds, so I would do I is less than 5, since I starts at 0. Then, at the end of each loop, I want I to increment by 1, so I make sure that this happens 5 times. Now I use a curly bracket after the for loop to encapsulate all of my code in here. So I would have an ending bracket here, and then, for ease of access, I tab the code over so that it's easier to understand what's in the for loop and what's not in the for loop. Because tabs, at a glance, you can tell instantly, oh, I see, this is nested in some other structure, which is a for loop. So let's see what that looks like. Ah, 5 beautiful clouds. And one's even going off the screen. So I can change that cloud x variable to be something smaller. And now we can see all 5 fit very nicely. So this is very convenient for changing where the clouds are. As a treat, I want to show you how to make those clouds vary a little bit using the random function. I'll talk more about functions in the next video, but by calling random and giving it 2 values, the min and the max, it will change the height of each cloud by some subset each loop, so their y values will change. So let's create a cloud y value. Let's call it cloud y, and set it to be 50, which is the exact same thing we have here. Copy and paste cloud y. And when we're changing the values, cloud x plus equals 60, let's change cloud y to be a random number between -20 and 20. This will set each cloud to be at a different altitude when it's created. So all of the circles will be at the same line, but the next cloud will be at a different line. Ah, that's very nice. If you notice, each time you run the program, the clouds will be in a different configuration. That's because random happens randomly each time the program is run. That's pretty cool. This is just the beginning of what processing can do. Tune in next time, and I'll talk more about functions and the benefits of using them.